Hello, and a very warm welcome to everyone joining us for today's Select Science Clinical webinar. My name is Frankie McDonald, and I'll be moderating today's presentation entitled Automating Urinalysis at the Point of Care, Improve Accuracy, Save Time and Reduce Costs. Our speaker today is Olubunmi Martindale-Sheldon, Point of Care Testing Manager of Northwest London Pathology. In this webinar, she will present her findings from her large comparative study of urine chemistry analysis methods across one of the largest hospital trusts in the UK. She will also reveal how 3 hospitals achieved streamlined point-of-care testing workflows with reduced cost and increased accuracy. Bunmi will be answering your questions in our live Q&A session at the end of her presentation. But please feel free to ask questions at any time during the webinar by clicking on the Ask a Question button at the bottom of your screen. You can view the presentation in full screen by clicking on the tab at the bottom right of your media window player. And for those keen to accrue their CPD points, you'll be automatically redirected to the relevant links at the end of the broadcast. And the on-demand link will also be provided a few days after the event. So just before I hand over to our speaker, we're going to ask you guys a quick poll question, which you should see appearing on your screen right about now. If you could select the answer that is most relevant to you, that would be fabulous. So the poll question is, please describe the urinalysis methods currently used in your facility. So option A, fully automated. Option B, semi-automated analyzers with results transcribed to patient record manually. Or option C, manual or visual read method only, no instrument-read urinalysis. So that's please describe the urinalysis method currently used in your facility. A, fully automated, B, semi-automated, or C, manual. Okay, great. So without further delay, I'd like to hand over to Bunmi. I hope you enjoy the presentation.
The title of my presentation is Automated Urinalysis Study, a Patient Safety Idea. During the course of this presentation, I will provide a brief background, including on Patient Safety Challenge Initiative, the aims of the study, the methods used, the findings from the study, a summary, and as well as present the conclusions. I'll provide a brief background on POC urinalysis and urinalysis at Imperial NHS Trust. POCT urinalysis involves carrying out urine chemistry tests at the point of care nearer to the patient and generally involves measuring analytes such as bilirubin, blood, glucose, ketones, leukocytes, nitrites, pH, protein, specific gravity, and urobilinogen, and that depends on the reagent strip type in use. These tests are generally very useful in assisting diagnosis and assessment of conditions such as metabolic disorders, kidney function, urinary tract infections, liver function, and also useful in measuring physical characteristics such as acid-base balance and urine concentration. As such, these urine chemistry tests are very popular and are in use in the majority of clinical areas across Imperial NHS Trust. In fact, over 150 clinical areas are using urine chemistry tests, are processing urine chemistry tests at the point of care, and with an estimated workload of over 300,000 tests per annum. So at Imperial, we generally use it as a screening test. So if any of these analytes, blood, protein, nitrite, or leukocytes is positive, then we send the sample to the lab and to the central laboratory for confirmation of further analysis. One of the key points to this study is the fact that the urine chemistry tests that we're carrying out at Imperial are mostly done via dipstick testing. So basically, this is based on color development and the ability of the user to accurately interpret the color type and intensity. And of course, it's quite subjective, open to interpretational errors, and does not meet relevant quality standards. Imperial College London launched an initiative to see how we can improve patient safety in the trust. So they put out an advert open to all staff across Imperial NHS Trust. So it was the first of its kind in the trust, and they invited everybody across the trust, across all grades, across all staff groups, to put forward patient safety ideas. And the project must have the potential to improve quality and patient safety. And regardless of the number of applications received, only 10 projects will be selected with a maximum of £30,000 per project. The Patient Safety Challenge Initiative application process involves submitting a patient safety idea by completing an application form. If shortlisted, present to a Dragon's Den type panel chaired by Professor Delord Aradazi. If successful, then funding will be provided. So I saw that as an opportunity because POCC, we do not have central funding for point of care, and it's quite hard to get funding for point of care. So as a POC manager, urinalysis testing via dipstick for me is an obvious safety risk. So I put forward an idea to see if they would be happy to fund that idea, and then we take it forward. So the case I presented was for automating urinalysis right from the start to the finish, basically from testing through to reporting. The panel reviewed my case, and I'm pleased to say they approved it. They approved the pilot project and provided funding of up to £30,000. I actually used the £30,000 for the project. So the aim of the study was to pilot fully networked automated readers and assess the benefits over the manual dipstick method, which is widely used in the trust, and semi-automated method, which is in use in a couple of areas, about 2-3 areas in the trust. Also, to determine the potential institutional and patient benefits, and if the pilot demonstrates significant benefits, the plan was to recommend rollout to the rest of the areas in the trust. So the methods used and the materials. What we did was we have 3 main hospital sites across Imperial NHS Trust. We have the Charing Cross Hospital in Hammersmith. We have the Hammersmith Hospital in East Acton, and then we have the St. Mary's Hospital in Paddington. So what we did was we randomly chose 3 clinical areas per hospital site with medium to high test usage. We chose them at random, and then making a total of 9 clinical areas. So what we did was divided these 9 clinical areas into 3 separate groups, each group, of course, comprising 3 clinical areas, and each group representing a method type. The manual method, semi-automated method, and the fully automated method. So this next slide is just showing what these 3 different methods are. The manual dipstick involves just using the reagent test strip. There is no reader, so the user will have to interpret the colors and write down the results, basically. For the semi-automated method, it involves using the reagent strip, but using a reader, an automated reader, to actually interpret the results and produce the report. So generally, these readers have a printer paper, so the user will get a printed result at the end of the testing process. And then lastly, the fully automated method involves using the reagent strips, the automated reader, as well as a link to the electronic patient record. So what sample types did we use? What we did was we tried to eliminate biases as much as possible, and we tried to replicate what we do in actual practice on the wards. So on the wards, the samples we use are IQC samples, internal quality control samples, external quality assessment samples or proficiency testing samples, as well as fresh patient samples. So the study included the use of all these all these three types of samples just to ensure that we are looking into all sample types and any variation that might result as a result of different sample types. So what we did, again, to eliminate biases, same set of samples were analyzed using all three methods. The resulting data were then compared with reference standards. For the IQC, we used the reference ranges provided by the manufacturer as the reference data. For the proficiency samples, we used the values provided by the scheme provider. And for patient samples, that was a bit of a difficult one to come up with, because not all the analytes are available in the central lab. So what we did was we got a competent POCC staff to carry out the test using an automated reader, and we used those values as the reference values to compare the results generated by the clinical staff on the ward. To ensure the values provided by the POCC staff as accurate as possible, what we did was we selected some samples and that have already been processed by the POCC staff, and we sent them to the central laboratory so that we can check that these values are close to the central lab values as possible. In terms of measurements, we looked at three key elements: data quality, governance, cost, and efficiency. Under data quality, we looked at how accurate the results are compared to the reference values. We also checked if there were any transcription errors. In terms of governance, we looked at staff training, internal quality control checks, external quality assessment. We looked at whether people were recording the results and how these are being recorded. We looked at reagent traceability, especially in terms of product recall. Are we able to retrace the reagents that are used? And we also looked at operator traceability and patient identification. Lastly, we looked at cost and efficiency. We looked at staff time, false positives, which means you have to send more samples to the lab than necessary, false negatives, which means you send somebody home when they actually have a condition. So we move on to the findings. The study showed that the manual method was only 70% accurate, whilst the automated method, the semi-automated and the fully automated methods were 85% and 87% respectively. That's what you'd expect for the automated system, because at this time we're not talking about linking to electronic records. So you'd expect that the result for the fully networked and the semi-networked and the semi-automated analyzers would be similar. So in terms of accuracy, therefore, the automated methods were 15% more accurate than the manual method. We also looked at accuracy using IQC and EQA samples. Both, all the methods, the fully automated, semi-automated, and manual methods, all demonstrated acceptable performance. However, improved performance noticed for the automated methods. The second element we looked at under data quality was transcription errors. And for the manual method, the study indicated 14% error rate compared to the semi-automated, which was 9%, and there was no transcription error recorded for the fully automated method. For the manual, what happens is once the test is done, then the clinical users will need to write down the results on a scrap paper, and then they go onto the computer and then enter the results onto the electronic patient record. For the semi-automated, once they process the sample, they obtain a printout, but that is still not a permanent record. So they have to go to the computer and then transcribe the results onto the computer, onto the electronic patient record. But for the fully automated system, the reason why it is 0% is because the results are automatically linked to the electronic patient record. There is no requirement for transcription. And the study showed that in pool as well. Moving on to governance, we started off with training. ISO accreditation requirements stated only personnel who have completed training and demonstrated competence shall carry out point of care, and records need to be retained. So what we did was we carried out an audit over the period of the study, and we found no record whatsoever for clinical users using the manual method, the manual data-take method. For the semi-automated and for the fully automated, however, we had 100% record, full records for those users. In terms of internal quality control, ISO accreditation requirement states the lab shall design quality control procedures that verify the attainment of the intended quality of results. The lab shall have a procedure to prevent release of results in the event of QC failure, and also frequency of IQC should be specified for each device. So we carried out an audit over a 3-month period of the IQC testing practices in place for each of these 3 methods. For the manual method, no IQC testing was in place. There was no standard operating procedure to specify what the IQC procedures are or what the frequency should be. Also, there was nothing recorded because they were not carrying out the IQC testing, and staff were able to use the device, the test strip, without carrying out IQC checks. Moving on to the second method type, the semi-automated method, staff were carrying out IQC testing and at the required frequency for the majority of the areas, i.e. for 2/3 of the areas. But for 1/3 of the area, they were carrying out IQC testing, but not as specified in terms of frequency in the SOP. IQC data were being recorded in POC record book, which the POCT team has issued to the clinical areas. And staff, in most of the areas, they were unable to use the device if IQC fails. But in 1/3 of the areas assessed, they were able to use the device. So still not standard in terms of what they were doing in terms of IQC checks. And the third method, fully automated method, IQC testing is being carried out in line with the required frequency, and the method of IQC recording is electronic, so the clinical users didn't have to write down the results. It's automatically done. So the analyzer actually looks at the results and let it inform the user basically if the IQC has passed or if the IQC has failed. And then staff with staff were unable to use the device if IQC failed. In terms of each external quality assessment proficiency testing samples, ISO accreditation requirement states, where available, participation in an EQA shall be required. In the absence of an approved EQA scheme, the lab director shall establish an IQA, internal quality assessment scheme, involving circulation of samples or replication of tests within the lab. So we carried out an audit again. We did of a questionnaire over a 3-month period. And for the manual method, none of the area was participating in EQA. Also, no standard operating procedure in place to let them know they needed to participate or what frequency, and nothing was recorded because nothing was done. For the semi-automated method, all the areas were participating in EQA testing and in line with the required frequency. In terms of the semi-automated method, all the clinical areas were participating in EQA testing. The frequency of EQA also in line with the SOP, and EQA data were recorded using POC record book, analyzer printouts, or EQA request form. However, for the fully automated method, only 2/3 of the areas were participating in EQA. And this was, I must say, when I was analyzing the data, I was a bit surprised with this. So we had to go back to find out why not all the areas were participating in EQA, considering it's the PhD team that actually registered the areas on EQA. So we realized that we were yet to enroll, the 1/3 of the areas on EQA scheme. So in terms of frequency, all the areas that were enrolled and registered were participating, and the data was electronically recorded. In terms of reagents, ISO accreditation requirements state a record shall be kept of materials and reagents purchased for POCT that allows an audit trail with regard to any particular test performed. With the aid of a questionnaire, we carried out an audit over a 3-month period, and for the manual method, there was no record at all for reagent information. The number of times the lot number of the reagents was recorded was 0, and staff were able to use expired reagents. For the semi-automated method, 87% of the time, reagent lot number were recorded. In terms of recording reagents information, they did record this for in the POCT record book, and also this is on the actual analyzer. There is an electronic record of that, of the reagent information on the actual analyzer itself, and staff were able to use expired reagents in 1/3 of the areas on the study. Lastly, for the fully automated method, 100% of the time, lot number of the reagents were recorded. The reagent information were automatically recorded electronically, and staff were unable to use expired reagents with this method. Moving on to operator identification, ISO accreditation requirements state POCT results shall be reported with necessary details. The identity of the person performing the test should be recorded. So we looked at the IQC test and the EQA test carried out throughout the study period. And for the automated methods, i.e. the semi-automated and the fully automated methods, for both automated methods, 100% of the time, you could actually identify the operators carrying out both the IQC and the EQA test. The reverse is the case for the manual, where you could not identify who was carrying out the IQC or the EQA test. The previous slide focuses on the IQC and EQA test result recording. This current slide focuses on patient test results recording. And ISO accreditation requirements states POCT results shall be permanently recorded in the patient's medical record. The identity of the person performing the test should also be recorded. At Imperial NHS Trust, our Cerner is our electronic patient record system. It's our hospital information system. And so this study focuses on which results are on Cerner for each of these methods. So for the manual method, 9% of patient results were not recorded on Cerner. For the semi-automated system, 3% of the results were not recorded on Cerner, and for the fully automated system, 12% of the results were not on Cerner, which is a bit counterintuitive because you would expect a fully automated method to have 100% of the results on our electronic patient record, Cerner. So after the study, after analyzing the data, what we did was we investigated to find out why that was the case. And we discovered that during the time when we were collating the data, there was an IT connection issue. So the IT system was down. As such, the data did not transmit onto Cerner. Having said that, the users did have the analyzer printouts that they could work on. Also, when IT connectivity was restored, all the data automatically transferred onto Cerner. But at the time of the study, when we were collating the data, the 12% of the results were not on Cerner. And it is important to reflect that in this study. The next set of elements that we looked at operators and whether these are correctly recorded on Cerner, because it is important that operators are traceable. So for the manual method, 81% of the operators were recorded. For the semi, 97%, and for the fully, 88%. Again, the 88% is because 12% of the results were not on Cerner, as such, the operators were not recorded as well. So moving on to the third key element that we measured during the course of the study, cost and efficiency savings. The third key element that we measured during the course of the study was cost and efficiency savings. On average, it took 19 minutes for the manual method from testing through to reporting. For the semi-automated method, it took 12 minutes, and for the fully automated method, 2 minutes, which means for the fully automated method, it takes 17 minutes less per test. So in terms of cost savings in staff time, time savings per test is 17 minutes. Number of tests per year is 300. We carry out over 300 tests per year. So that translates to total time savings of 5,100,000 minutes, and in hours, 85,000. So, and that translates to a total cost savings per year in staff time of over £1 million, which is quite significant. So the other elements we looked at under cost and efficiency savings included duplicate testing, so the false positives, because if any of the tests shows positive result for any of those 4 analytes I mentioned earlier, then a blood protein nitrite or leukocyte, we have to send the samples to the lab. So, so if it is false positive, that means we are testing unnecessarily. Of course, that impacts on the laboratory resources as well. Also, we delay patient management because then we could have acted sooner. So for the manual method, 9% of the time, we duplicated the test. And for the semi-automated, 2%, and for the fully automated, 1%. Again, the automated methods are quite similar, and that's what you'd expect. So that means 7% fewer samples were sent to the lab for retesting with automation. Moving on to the missed condition, the false negative, whereby you tell a patient, oh, you don't have a condition, you can go home, whereas they actually do have that. What we found with the manual method is 14% of the time we missed the condition, semi-automated 4%, and fully automated 5%. So again, the automated method similar, and which means we were able to reduce the number of missed conditions from 14% to 5% with automation. Data quality was at least 15% better with automation for patient samples. So that includes both the fully automated and the semi-automated methods. And in terms of transcription error, there was no transcription error recorded with the fully automated system. Moving on to the second element that we measured, governance. In summary, only the fully automated system complied with all the quality standards assessed. We did note some issue with results data transmission, though there was no data loss. For cost and efficiency, in summary, we observed much less false negatives for the automated method when compared to the manual method. For the automated method, we observed about 5% false negative compared to 14% for the manual method. In terms of false positives, this is much reduced for the automated method compared to the manual method. Again, for the automated method, about 2%, and for the manual method, 9%. And finally, the full automated system saves 17 minutes per test on average compared to the manual dipstick method, with an estimated cost saving of over £1 million in staff time. In conclusion, both automated methods on the study performed significantly better than the manual method in all areas assessed. However, the full automated system demonstrated additional benefits when you compare them to the standalone analyzers. Fully automated system relies on active IT links, so there may be an issue if network problems occur, as demonstrated in this study. Implementation of fully automated system also will have capital and ongoing cost implications, and this should be considered prior to implementation. The fully automated system demonstrated significant benefits clinically, operationally, and financially. It's 15% more accurate, with fewer false positive results and less duplicate testing. It eliminates transcription errors completely and subjectivity associated with visual retest. Operationally, it ensures appropriate quality control checks are in place and are carried out prior to device use. It also prevents use by untrained operators. Additionally, it automatically logs and stores reagent information, ensuring reagent integrity. Financially, it ensures appropriate recording of results with no loss of data and significantly reduces the amount of time spent per sample, 2 minutes compared to 19 for manual tests, with potential cost savings. Thank you very much for listening.
Fantastic. Thank you so much, Bunmi, for a really informative and enjoyable presentation there. So now it's time to move on to the final part of today's webinar, question and answer session. So we've had lots of great questions come in from our attendees. The first question is, could you please explain further the difference between semi-automated and fully automated methods of urinalysis in your organization?
Thank you for that question. Both methods require the use of automated readers and getting printed results from the analyzers. However, the semi method requires users to manually transcribe the test results onto the patient's electronic record, and that has potential for transcription errors, especially as we have about 8 to 10 test results to transcribe at any one time, depending on the reagent strip type. This, of course, is also time-consuming and time that can be better used elsewhere caring for our patients. The fully automated system, on the other hand, does not require any manual transcription, as the analyzers are linked to the patient's permanent record, and so test results are automatically transmitted into the patient's electronic record system.
Fantastic. Thank you for that. So next question is, do you have any anecdotal evidence from users? Did they have a preference of the urinalysis methods used?
Thank you. Good question. Yes, we've observed situations where clinical staff using the manual method have not waited for the required timing in order to complete the test before they actually interpret the results and record the results. Some users do not have any watch on them. Some dip the strips into the urine, wait a few seconds, and interpret the results. Some other users have also complained about lighting in their test areas, which may impact interpretation. Also, color blindness can impact negatively on the test results. It is worth mentioning that since this study, we have seen an increase in the number of requests for the automated readers at Imperial NHS Trust. The only thing we find, though, when we've implemented these automated readers in new areas, is that clinical staff feel this takes more time because now they need to scan the patient's ID and the user ID, which they were not doing previously. But what we do is we explain to them that from testing through to reporting and ensuring results are accurate, the automated system is actually better. And we also use data from this study as evidence for them to see how much time they are saving in the long run. So getting them to look at the bigger picture, not just the initial testing.
Fantastic. So another one of our attendees was wondering whether Imperial College Healthcare uses the same urine analyzers across all of the clinical areas which participated in the study.
Thank you. Yes, all clinical areas that participated in the study use the same urine analyzers, the Clinitech Status Plus analyzers. And of course, this only applies to the semi and the fully automated areas.
Great. So next question is, what is the cost of the fully connected method or automated method?
So, thank you for that question. I'll be unable to give a cost because they are different in every country. If any of the registrants would like that information, they should contact their rep directly.
Fab. Thank you, Bunmi. So our next question from one of our attendees is, were you surprised by the 14% error rate for manual methods that you uncovered in your study?
No, not really. I was actually concerned based on what we have seen staff do on the ward, that things were at times not being done properly. And that was why I jumped at the opportunity to participate in the patient safety challenge, because the problem we have is POCT do not have central funds. So these are funds individually by the clinical area. So even if you see something is, needs to improve, there isn't any central fund you can just go and use to implement, whatever changes you need to implement to improve quality and safety. So when I saw the patient safety challenge advert on our intranet, Trust intranet, open to all Trust staff, as POC manager, I thought, wow, it's going to take a lot of work and effort, but this is a good opportunity in order to at least get evidence to show to the Trust, at the right level that, there are issues there and we need some things to be done about it. So now we have data evidencing the scale of these issues, including what can be done to mitigate the issues.
Great. So another one of our attendees was wondering, how are you going to take this forwards across the whole Trust?
Since the study, actually, we've taken it forward. What we did was I produced the report. The report was approved by our clinical lead, the POC clinical lead, who was the senior responsible officer for this project. And then we took it to the POCT management group for the Trust, the POC committee. That's the group that is responsible for the acquisition and introduction of POCT and safe use of POCT across the Trust. And also we took it to, different meetings, high-level meetings, and, everybody agreed because, the data clearly shows, things need to change. Again, it's the funding aspect of things. But having said that, because we have this evidence and, the people on the ward, the managers in the clinical areas themselves, they are now asking for putting in requests to the POC committee for new automated readers. And since the study, we have, significant number of Clinitech analyzers now compared to about 3 before. Now we have over close to 20. So, it's increasing, and I'm aware of an application that has recently been submitted that will go to our next POC committee meeting as well for approval. So, yeah, the things are getting better.
Brilliant. So we've had lots more questions come in. So the next one is, was there any cost savings with quality control utilization on your studies?
That's a good question. And for the study, I would say no. But we are aware that we're currently looking at how we can improve or reduce costing for QC, because currently the QC that we use, we have to reconstitute them and then send them to the, to the clinical area. So we're looking at QC schemes that can provide QC solutions so that we don't have to make anything up. And and also it seems would save money as well. So that's something we discussed at our last POC management group. But for the study, we just used what we are using at the moment. So there is no cost saving when it comes to QC material. But in terms of the time taken to process the QC, if you look, I think slide 22 or so, I can't remember now. I need to go back to the slides. But if you look at the slides, for the EQA and the IQC, there isn't, I would say in terms of the time that it takes, it's the same, regardless of whether it's IQC, EQA, or patient sample. It's the same time it takes from testing through to reporting. So I'll leave it at that, I think.
Fantastic. Thank you for that, Bunmi. So our next question is, so one of our attendees was wondering, the fully automated system seems to save costs significantly, but in the study was consideration given to the cost of purchasing and maintaining the automated analyzers?
Again, I think I mentioned that in one of the second to the last slide, saying there will be implication in implementing fully automated system, and that is, the actual the purchase of the analyzers and the IT costs and all that, and that will need to be reviewed, and the trust will need to be happy that they're happy to pay for that in the long run.
Fantastic. So I'm afraid that's all we've got time for today in terms of questions. Just want to take this time to say a huge, huge thank you to Bunmi for today's really informative discussion and presentation there. And thank you to everyone joining us online for your really interesting questions. I hope that this has been a truly worthwhile session for you. And if we didn't manage to answer your questions, then please feel free to email me personally at frankie.macdonald@selectscience.net. I can follow up your questions. And if you'd like to listen again to today's webinar, it will be available on demand in a few days' time. Just look out for an email from Select Science for the on-demand link. And don't forget to stay tuned for access to your continuing education credits. After the broadcast has ended, you'll be automatically redirected. So that's it. Goodbye, and thank you once again for joining us.
Thank you.